Okay, doggies. Today we're going to have our first lesson in mathematics. Sound good? I'm not too excited about that. Alright. The basic mathematics. So in mathematics, we usually start learning about numbers, right, Ike? Yeah, numbers. Like 1, 2, 3, right? And that's cool. And we learn, you can count one finger, you can count 2 fingers, and if you have 2 fingers in one hand that you're holding out, and then you have another finger in another hand, you put them together, you call that 3. Right? That's cool, right, Dino? Hey, Dino. I need to clean that bag up, don't I? Hey, so remember, like with mathematics, so we're doing a mathematics lesson? Yeah. So we're talking about numbers, like 1, 2, 3. And so that's easy to use them to count, to measure, to figure out how much something costs. Let's say, hey, so minus 7. Like, let's say you had a weight of gold that's worth a certain amount of money, right? So that's a good way to figure out how something costs, by measuring the weight. And those are all different numbers and different dimensions. Hey, Dino, come here. We're having our first mathematics lesson. Can you sit for me? Can you sit? Not quite? Alright. Remember how to sit? I don't want to. Yeah, I know you get nervous. Alright. So, the thing is, that works fine. But when you want to think about what a number really is, like what is a number 1? And why if I have 2 number 1s and I add them together, why do I get 2? Like, what is the underlying structure of mathematics? Right? And that's when we start getting interested. So we can talk about numbers in terms of bricks, but we can also talk about numbers in terms of like locations, right? So with bricks, it's pretty easy to understand if 1 is like some abstract quantity, like an amount of something, right? And 2 is another abstract quantity, then it makes sense that 2 1s together would make 2, right? Yeah, right? So we take those abstract quantities and we project them into various number of dimensions of spaces, right? We do that abstractly in mathematics. And when we do that, Ike, when we take these numbers and associate them with basically locations in interesting universes of dimensions, right, with different kinds of properties like addition and multiplication, then we can explore what happens in that kind of universe. It's like the most intellectual land of make-believe there is, right? See what I mean, minus 7? Pretty much. I mean, you can't get more make-believe than that, and you can't get more intellectual than that. I mean, you can, but it's just very, very intellectual, right? There are different ways to be intellectual, so pardon me if you're, say, like a philosopher and you didn't appreciate that. Because I think, are you the philosopher, or you look like the philosopher, right? You need to think about what you want to think about, and how to think about it, and why, right? Okay. Alright, so we can take these numbers. Hey, Dino, come here. So what we can do in physics is we take these numbers that now, they can be quantities and they can be locations in interesting universes that we construct. Alright, we can take that and then we can add physical properties, which align with the properties of the universe. Like electric charge and electron spin, right? We can add all those things, and we take all that and we build a really good model. Then we take the most complex things in the world and we put them into that model and process it in a simplified way, or just in a very methodical, computable manner. And then we figure out the answer, right? So it's something we're trying to find out in life. So we started out figuring out how much we're going to sell our grain for, and then we grew our brains to infinite dimensions and different level count, or different types of infinite sets of numbers, right? And all that kind of stuff. And then we ended up to the tiniest pieces of the universe. I mean, maybe there's gonna be more tiny stuff, but for now, that's what we're looking at. As far as we know, the tiniest stuff in the universe, and trying to figure out how to put it in a model so that we can process it in a computational way and come at an answer to provide some kind of result. Build a machine, figure out, I don't know, when the sun's going to turn blue, or when the sun's going to expand over the earth, all that kind of stuff. So anyway, all that to say, hey, are you paying attention, Minor 7? Minor 7. You're thinking about, like, whether you're a rationalist or an empiricist. Yeah, you're the philosopher. That's cool. Don't worry about it. But anyway, all to wrap up, the first lesson in mathematics is that is what mathematics is. Right? Looking at numbers, but what are numbers really? Are they collections of things? And looking at spaces where numbers can exist, and how are these numbers or objects or places or locations with properties? How are they going to behave because of the properties of the universe they're in, and all that kind of thing? And then we can send someone to Mars someday, right? That's more than mathematics. Mathematics is just exploring how these things within a model that we create work. Right? That's all it is. All right, that's the end of the lesson. You think they're ready for the quiz? It's quiz time. Hey, Ike, Dino, come here. It's quiz time. I hope you're paying attention. Quiz, your first quiz for Mathematics 1, Lesson 1. Ike. Hey, girl. It's quiz time. All right, quiz time. All right, I'll let them take their quizzes. You guys, you can take your quizzes in peace. I'll turn the camera off, and then we'll grade them.